Hello everyone, welcome to an algebra tutorial video learning about factoring by grouping. We're going to go over another example here. We've got a 4-term polynomial. This example I wanted to give a multivariable, so we got both m and n here. But we can still use factoring by grouping to try and break down this 4-term polynomial into smaller binomials multiplied together. So we're going to run through our factoring by grouping steps, go through them, explain them, and make sure you're getting another good, solid example of how to do it on your own. All right, step 1. If I want to do factoring by grouping, we need to form two groups. With 4 terms, we form two groups of 2. And with that, careful with negatives, careful with subtraction. I want to make sure when I'm adding my parentheses, I'm not changing the polynomial. So what we did is we changed everything into adding with a negative. So I changed it to plus negative 4mn and plus negative 12. And now I have 4 things being added. Now it's okay to go ahead and form two groups. So I'm going to form the blue group, put the first 2 together, m squared plus negative 4m times n plus, and then my other group, 3mn plus negative 12n squared. All right, step 1 is done. We formed two groups. Step 2, factor the greatest common factor out. Greatest common factor from each group. All right, so we're going to look at each group at a time. Let's start with the blue group. What is the greatest common factor between these two terms, m squared and negative 4mn? Well, all I'm seeing is just a common factor of m. There's no n's in both of them. And in terms of coefficients, there's a 1 and negative 4. There's nothing common there. So we're going to pull out, factor out my m. And what do we have left? Well, we have 1m plus negative 4n. Those m's just divide out right there. All right, let's take a look at my second group. What's in common between these two terms? Well, between the 3 and the negative 12, I have a factor of 3. No m's in common, but I do have a factor of n in common. So I'm going to factor out the 3n. And what do I have left? We have one term of m, the n's divide and the 3's divide, plus negative 12 divided by 3 is negative 4, and n squared divided by 1n leaves just 1n. All right, there we go. We factored out the greatest common factor from each group. Now, step 3, look for common binomials. Common binomials and factor them out. So here we go. We've got one binomial here, m plus negative 4n. And I have the same binomial, m plus negative 4m. I'm feeling really good. This is going to work. If I didn't have common binomials, I'd be stuck. I wouldn't factor. And sometimes you get polynomials that won't factor. But in this case, we do. We have common binomials, so I can factor those out. I'm going to pull that common binomial. They're just multiplying m and 3n. So I can divide those out. And I'm taking my m plus negative 4 times n. And what do we have left? Well, we have an m plus negative 3. Or m plus 3n, sorry. And there we go. We have just successfully factored our 4-term polynomial into m plus negative 4n and m plus 3n. Now, it doesn't matter the way I wrote these. I could have written this one first and the other one second. I could even change it back into subtraction. So this is the same thing as this, and this factored form is the same thing as what we started with up there. So there we go. If we wanted to double check, we could just use our multiplication methods and distribute this all out and see that we would indeed get back to this polynomial up there. But there you go. There's an example of using factoring by grouping to take a polynomial with 4 terms, go through the process using our greatest common factors, using grouping, and turning it into in this case, 2 binomials multiplied together.